Okay, it's just after the hour, so let's get started. Hello, everyone, and welcome to the Water Board Seminar Series. My name is Jarma Bennett, and I'm a Senior Water Resource Control Engineer with the State Water Board's Office of Information Management and Analysis. Thank you for attending today's seminar. All seminars are open to the public and recorded for posting in the details of the corresponding events in the College of Water Informatics events page. There will be a question and answer period at the end of the talk, so please hold your questions until today's speaker has finished their presentation. Everyone except the speaker will be muted until this time to avoid disturbing the talk. During the question and answer session, we will post a very brief feedback survey so we can get your feedback regarding our series and hopefully improve them as needed. Today's speaker is David Altair. David is a Water Resource Control Engineer in the Office of Information Management and Analysis at the Water Board. He joined the board in 2015 and primarily focuses on creating tools and applications to help manage and analyze data for multiple programs and projects at the board. He also helps support the board's open data efforts. Prior to joining the state board, he worked as a consultant developing and applying computer models to support water supply and flood management planning studies. He holds BS degrees in civil engineering and biology from Virginia Tech. So with that, I'm going to hand it over to David to talk about redlining in California. Thank you, David.
Thanks, Jarma. Thanks, everyone, for joining today. Give me a second to share my screen.
I can see it now.
Great. All right. So yeah, so like Jarma said, I'll be talking today about this sort of exploratory type data project that I've been working on with a couple of other folks for, I guess, about the last year or so. And so it's looking at the sort of historical practices of redlining and looking at some of the potential relationships between that and the CalEnviroScreen data set that we have. So one other quick thing to know before we start, I have attempted to put these slides online. So if you look in the lower left-hand side of the screen, there's a link there. I think you can find the slides there. If there's any links that you'd like to look at later on, or anything else you want to look at on your own time. So bit of an overview of what I'll be talking about today. First, I'm going to cover a little bit of background and context for the work. But as you probably gathered from Jarma's introduction, I am definitely not a trained historian or social scientist or anything like that. So I'm definitely not here to give you a comprehensive history on redlining or anything like that. And certainly there's a lot of personal stories behind all the statistics and policies, and I'm certainly not here to tell anybody's story for them, of course. So hopefully just going to be giving you enough history to understand the context for this work. And then after that, we'll be talking about the actual analysis itself, including some of the data sets that were used and going into some of the results. And then I'll talk a bit about some of the presentation formats that we've developed to sort of start sharing this work publicly. And then talk a little bit about some of the tools and methods that at least I used in my work, my part of the project, and then closing out, if there's time, with some considerations on sort of how to interpret the data from my perspective, and some of the limitations and some potential next steps going forward for similar types of work. So before I jump into the history, I did want to mention that, like I said, this is definitely part of a much larger effort, larger team effort. You might have heard that there was a story map released by this team back in early February of this year, and it was, and I think still is, advertised on the CalEPA homepage. So you can find a link here if you'd like to take a look at that at some point. If you don't know what a story map is, no worries. I'll show you a brief demo and talk about that a little bit later. But like I said, this was part of a much larger team effort. It's kind of a side project, I guess, for all of us, but lots of different people made lots of good contributions. So certainly can't take credit for a large portion of it. So now into a little bit of the historical background of what redlining actually is and what I mean when I say that term in the particular context of this work. So if you kind of just go online or look around, I think you'll see a lot of standard definitions that are kind of referring to redlining as somewhat of a generic practice that can be, something that could have happened throughout history at different time periods, and could be, both public and private actions. And I certainly don't have any issue with those definitions, but I did just want to point out that in the context of this project, when I say the word redlining, I'm actually referring to one very specific and well-documented redlining practice in particular. So that is the creation of these set of maps that were drawn up back in the 1930s that are referred to as residential security maps. And they were drawn to show major cities throughout the country, only those that had a population of at least about 40,000 or greater back in the 1930s. So that included 8 cities within California, which you can see here listed. And then on the right, you can see an example of actually one of those maps, the original map that was created back in the 30s. And so a little bit of background about these maps themselves. They were created kind of under the oversight of a federal government agency called the Homeowners Loan Corporation, or HOLC. I guess sometimes people just refer to it as the Hulk. So this agency was kind of charged with buying mortgages that were at risk of default from homeowners, and then sort of reissuing loans to those same homeowners, but on more favorable terms. And of course, this was all done in the New Deal era, so kind of in the wake of the Great Depression, trying to prevent widespread foreclosures. And there were other agencies that kind of existed to try to support new home buyers to be able to buy homes. But this particular agency was just charged with kind of shoring up those existing mortgages, from what I understand. And so the way that they did that, or sort of to support their efforts, they had this program to evaluate mortgage lending risks across the country. So that's where these maps came in. And so they made these evaluations on sort of a to D scale. And they also used color codes. So that's where the term redlining actually comes in. So the neighborhoods that were given a green score that were colored in green in these maps were given the best scores. So, that's sort of the best risk rating. And then neighborhoods that were given that were colored red were given sort of the worst or highest risk rating on the maps. So here's just a zoomed in view of the map of Sacramento. And one other thing I did want to point out is that, well, so if you zoom in onto the legend, again, you can kind of see their rating system. And I did want to point out that, you know, for the rest of this talk, I'll mostly be referring to these maps as sort of the redlining maps, but it is important to note that they don't actually just show areas that were, you know, given as red high risk ratings. They actually show sort of the whole range of good to bad. So like I said, the maps were drawn for several different cities. So here's just another example of the one for the Oakland area. And then another important thing to consider about this program is that they were very explicit in considering the racial and ethnic makeup of neighborhoods when they made their assessments. Like I said, I'm not a historian, so you know, you don't have to hopefully take my word for it. But a lot of my understanding of the, you know, history around this practice, and I think a lot of the project teams as well, comes from this book by historian Richard Rothstein, who the book is called The Color of Law. So he explores a lot of this history as well as a lot of other related history related to housing discrimination. So the way that we actually know that race was very explicitly included in these assessments is because the surveyors that were hired to carry out the task filled out these assessment forms for each neighborhood that they graded to kind of justify their rating. So this is a scan of one of those original forms. So if you zoom into this is kind of the top part of one of the forms for an area, a neighborhood in Sacramento that was given a D or red risk rating. And so, you know, if you look at the top, there's a heading for area characteristics, you know, section 1. And if you look down to 1C, you can see they talk about detrimental influences. And then in this case, they very explicitly talk about subversive racial elements. Then if you look down at the second section, they very explicitly talk about the makeup of the inhabitants. So they have a section for foreign-born families and 2C, and then they have a whole section on their kind of standard forms that calls out the percent of the population that's Black in 2D. So, you know, on this form and throughout Sacramento, I think you see a lot of Asian American and Latin American communities called out. But, you know, throughout the country, certainly there was a large focus on the Black population as well. And then, so all of these practices, you know, very likely had resulting impacts on the trajectories of the communities where the maps were drawn. Again, just another quote, so you don't have to take my word for it. But there is some debate about, you know, how these maps were actually used. But as this, you know, kind of says, they very explicitly put the federal government on record as making a judgment about how race related to credit risk assessments. And there was a webinar recently by some researchers that have been looking into this and have, well, I'll be talking about a little bit later, have made a lot of the data available. I think he described it as, you know, putting a thumb on the scales for these neighborhoods. So it wasn't necessarily deterministic, but it definitely likely had some major impacts, as we'll talk about on this slide and upcoming. So there have been a lot of other studies already that have looked at the effects of redlining, and I just wanted to mention a couple. This one in particular was done by the Federal Reserve Bank of Chicago. And this one is focused on the economic impacts of redlining, and it's a pretty detailed study. I kind of skimmed over it a little bit, and they actually try to dig into some like defining levels of causation. So they use some pretty sophisticated methods, it seems like, and they're fairly conservative in their findings, because of course it's pretty difficult, I think, to actually draw out causation from this type of data. But they do say that they found that these maps had an economically meaningful and lasting impact on the neighborhoods where they were drawn. So there have also been some recent studies looking at sort of more environmentally related and public health related sort of tie-ins to the redlining maps. And these really kind of served as some inspiration for the work that we did that I'll be talking about in a minute. So this one looked at redlining and asthma rates, and again found that those redlined areas had significantly higher rates of asthma. And another study that's been talked a lot about recently in the news is this study looking at the tie-ins between redlining and tree cover and the urban heat island effect in different cities. So you can see here kind of a simplified version of their results, where neighborhoods that were rated A are kind of given the best ratings back in the 1930s now have significantly, well, not always, but in a lot of cases have lower temperatures than neighborhoods in the same cities that were given lower risk ratings. So one other thing that I just kind of wanted to touch on briefly is that, like I said, I'm mainly just talking about this one specific practice of redlining in this talk, but of course, it sort of connects with a lot of other historical policies and practices. And one important one that really I thought was interesting from this book that ties into a lot of the environmental and health related impacts of different racially disparate policies was the practice of economic zoning. And he mentions this specific example of Los Angeles, and how in the 1940s in the south central area of the city, it sort of became more and more non-residential as it was rezoned for more commercial and industrial use. And so things like an automobile junkyards became more commonplace. And then there was even a explosion at an electroplating plant that killed a couple of people there. So what I thought was interesting about that is sort of the way that this also tied back to the idea of these lending practices, because they would often sort of in effect make areas ineligible for those loans due to the presence of those land uses that were allowed by the zoning practices. And then that kind of led to this sort of reinforcing effect where those areas, since they didn't get loans because of the land uses that were allowed, then had less resources for upkeep. So then likely made it less likely that they would get new loans, and made it probably easy for the zoning practices to kind of continue to allow more and more of those types of polluting land uses. And similarly, the fact that a lot of the zoning ordinances also protected the whiter residential areas, sort of also effectively forced a lot of polluting industry into communities of color. So I thought that was kind of an interesting tie into some of the other historical policies. with redlining. So it certainly makes it kind of difficult to just isolate the effect of redlining, but certainly makes its effects that much more substantial. So now I'm gonna get into a little bit of the analytical part. So all these redlining maps that I've been talking about have actually been digitized by this project called Mapping Inequality. I think it's mainly a group of researchers at the University of Richmond and Virginia Tech and a few others. So they have gone through, and I think for pretty much the whole country, have digitized all of the maps so that they can be used in like a GIS type of analysis. And so if you go to the website and click on the downloads and data link, which you can kind of see there at the top, you can actually download any of the images. You can get the geospatial data. That GeoJSON link actually includes the kind of raw text from those area descriptions that we looked at just a second ago. So you can actually do sort of text-based analysis as well, and some folks have already started doing that. So that's one, great resource that we already have that makes it easy to analyze this data. Then another great resource that kind of lends itself to this analysis that we have is CalEnviroScreen, which provides us with a really great indicator of sort of broad-based present-day environmental and public health conditions throughout the whole state. So I'm sure a lot of you are probably pretty familiar with CalEnviroScreen. There's actually a new, I think still a draft version, 4.0. So in this analysis, we're still using 3.0, but we'll probably update it to include that new 4.0 data once it becomes final. But if you're not familiar with CalEnviroScreen, just really briefly, it is a mapping tool that was created by the Office of Environmental Health Hazard Assessment, I believe, at CalEPA. And so it was developed with kind of the specific purpose of identifying communities that are both at risk or that sort of have the highest pollution burden levels, and also those that are most vulnerable to the effects of pollution due to various socioeconomic factors. So it's a pretty wide-ranging data analysis sort of project that includes data from environmental sources, as well as health data and socioeconomic data. And then the sort of output is a numeric score, and the sort of geographic scale is the census tract level. So it produces a score for every single census tract in the state. So there are actually 20 different indicators included in CalEnviroScreen. You can see those here. Like I said, they fall into two broad categories of pollution burden and then population characteristics that make the residents especially vulnerable to the effects of pollution. And like I said, all those 20 indicators are ultimately combined into one ultimate sort of CalEnviroScreen score, but you can also look at the scores for each individual indicator as well. So that's a really great data set that kind of lends itself to analysis similar to what we looked at with the asthma study and the urban heat island study. So we figured it'd be kind of low-hanging fruit, I guess you could say, to try to do something similar. So we did that, and the first step was to just sort of overlay the two different data sets. So here you can see, this is Oakland, and on the right, you can see all those neighborhoods from those redlining maps in the 1930s. Again, those are the digitized data that we got from the Mapping Inequality project. And then on the left, we've overlaid those neighborhoods, which are kind of the different colored lines, on top of the CalEnviroScreen data. And even here you can kind of see visually some of the trends between the, I guess you could say correlations between the two, where the red polygons on the right sort of correspond to the more redder and lighter green colors on the left map, and then the green and blues on the right, those areas that were given the best grades in the 1930s, still today have the best sort of environmental scores and the lowest population vulnerability to pollution. So this is just another similar example of the Stockton area where you can kind of see the same thing with the sort of northwest part of the downtown area being the areas that were given the best ratings in the 1930s and still having roughly the best environmental conditions today. So we looked at those maps, but also thought it would be kind of interesting to try to do a little bit more of a quantitative analysis to see, exactly how well these trends that you can see visually, how strong they are, how well they hold up in different areas and things like that. So the first step of that analysis was to try to basically translate the scores from the census tract level, the CalEnviroScreen scores from the census tract level to the neighborhoods and the redlining maps. So this is sort of a quick overview. If you follow that neighborhood that's circled in on the left side through, you can kind of see the process where we take that neighborhood from the 1930s maps, then overlay that on top of the CalEnviroScreen data, clip out just the overlapping parts in the third pane from left. And then on the right side, we, in this case, calculate the score just using a pretty simple area weighted average method. We also looked at least one other method for doing that translation. This is showing a method that matches the centroid of each neighborhood in the redline maps with the nearest centroid of a CalEnviroScreen polygon, and then just gives each neighborhood that score from that individual census tract. And so, of course, these aren't super sophisticated ways of doing that translation, and there are certainly better ways. This doesn't consider how population density is distributed throughout the neighborhoods or how the pollution burdens are distributed. So ideally, it'd be great to do something like recalculate the CalEnviroScreen scores for each neighborhood, but we did not do that. That's, I think, pretty far outside the scope of this work. Like I said, this was kind of just an exploratory data analysis project. But we did take a look at the comparison between those two methods just to see, whether there would be any big difference in the scores that we get using the two methods. And fortunately, it looked like, so what we've done here is just plotted the score for each of those neighborhoods from the maps from across all the cities. So the score that we get using the area weighted average approach on the x-axis versus the score that we get using the centroid approach on the y-axis. And ideally, if they were the same, they'd all fall along that one-to-one line that's shown by the dashed line. And fortunately, it seems like the overall trend does fall pretty close to that line. Of course, there are some outliers for some individual neighborhoods, but overall, it doesn't look like there's any bias, by grade or anything like that. And it looks like the overall trend is that they match up reasonably well. So I think that gives us at least some confidence in our sort of that process of translating the scores to the CalEnviroScreen scores to the Redline maps. So then we actually started looking at the trends. So this is plotting again all of the neighborhoods as each neighborhood is shown as an individual point. The neighborhoods from the Redline maps, that is, and they're colored by the score that they were given in those 1930s Redline maps, and then the position along the x-axis is their actual CalEnviroScreen score. So you can already see some trends. Of course, there's big differences between the cities and the scores, as well as within the cities. So you can kind of see here, I think generally the reds and yellows tending to fall on the right side of the graph, which indicates higher CalEnviroScreen scores or more pollution burdened and impacted areas, whereas the greens and the blues, I think you can kind of see, tend to fall more on the left side of the graph. That becomes a little bit more clear if you look at the averages by the rating that was given in the 1930s Redline maps for each city. So here, you can see for 7 of the 8 cities, areas that were given those green ratings today have the lowest CalEnviroScreen scores, relative to other neighborhoods in the city, and red neighborhoods have the highest CalEnviroScreen scores. But you can also see, of course, here that just which city a neighborhood falls in also has a really huge impact on its score, probably bigger than even what rating it was given in the Redline maps. So that makes it difficult to really compare the data between cities if we just use this raw data. So what we did is we tried to do just a very simple method to control for those differences. So we calculated this adjusted score, which is a pretty simple process of just taking each neighborhood in the Redline maps and then subtracting the average score for the city that neighborhood falls in. So you can see that kind of re-centers all the data around 0. And now it sort of makes it possible for us to compare the data across all the different cities and sort of combine it all together. So that led to, I guess you could say, sort of like the main outcome from this analysis, which is, I guess, sadly, as you might kind of expect, the neighborhoods that were given the neighborhoods that were redlined in the 1930s maps still today have the highest CalEnviroScreen scores, and each of those little dots represents a neighborhood that falls, that was given that rating. And again, these are using those adjusted scores. And so you can see the trend sort of follows the rating that was given in those 1930s maps. And so this plot is maybe a little bit misleading, so I don't focus too much on the details, but essentially I just wanted to show that also, if you look at those 20 individual indicators, 18 of the 20 follow that same trend, where, so, for instance, asthma, if you look at the top, areas that were redlined in the 1930s maps still today have the highest rates of asthma, and green rated neighborhoods in the 1930s maps have the lowest rates. So the two that don't follow that trend are drinking water and ozone. And that maybe kind of points to one of the limitations of this analysis. Of course, as we saw from those maps, the areas that we're looking at are pretty limited to kind of the core parts of these cities. So they're not really widely distributed. So something like drinking water or ozone might not be too likely to vary significantly within those small areas. But certainly, yeah, I think that could depend on the particular methods that you're using to sort of score all the indicators. So, of course, I'm sure CalEnviroScreen isn't perfect and it doesn't necessarily take into account every single possible, piece of data. So there might be other ways of looking at those indicators that might give you different results. So one last piece of the analysis, we wanted to look at the present day demographic conditions in those areas that were in the Redline maps from the 1930s, just to see if those disparities in environmental conditions that we saw from this analysis are still kind of applicable disproportionately to different racial and ethnic groups. And we did essentially find that that is at least somewhat still the case. So essentially, if the different racial and ethnic groups were all evenly distributed across the different neighborhoods that were in the 1930s maps, the lengths of each color of the bars for each group would be the same. But since they're not, you can see the white population is essentially overrepresented in areas that were given those green or best ratings in the 1930s. And African American, Native American, and Hispanic groups are overrepresented still in the kind of C and D rated areas from the 1930s maps. All right, so that's kind of a high level overview of the analysis that we did. So now I wanted to talk a little bit about some of the different presentation formats that we've developed to try to present some of these results. So there's kind of two main formats. The first one that I mentioned before is the story map. That's kind of an Esri ArcGIS product. So that was designed to give kind of a detailed history and a lot of the context behind the Redline policies and maps that we've been looking at. It also contains some interactive maps so that users can explore that data pretty easily themselves and take a look at the text in each of the forms from the analysis, the area description forms that were produced. And it gives kind of a high level overview of the analysis that we just went through. So actually doesn't quite cover as much detail as we went into just now. But for users who do want to take a little more detailed look at the analysis, we also developed a web application built using this this software called Shiny, which I'll maybe talk about a little bit later. But so this is both shows the analysis and also includes a few other features and might be built out to include a few more. So right now it can also help to view some of the CalEPA regulatory data in the context of this kind of redlining policy that we've been talking about. And the links are available to those here. So I wanted to give a really quick demo of those. Not going to spend too much time because we've already covered a lot of it, at least a pretty high level overview. But here's the story map that I mentioned. And like I said before, this was definitely not something that I can take credit for. This was a big team effort. But like I said, this provides a lot of the history around redlining and goes into a lot more detail of some of the other related practices like Federal Housing Administration policies. So a lot of interesting stuff there, and I encourage everyone to check it out if you get a chance. There are also, like I said, some interactive maps that you can use to view all the different cities in California, and you can actually click on maps and see excerpts of some of the text in those area description forms, and you can also actually get links to view the original forms yourself. If you scroll down a bit more, you'll find another map that lets you actually look at some of the CalEnviroScreen data that we've been looking at. And then there's, like I said, kind of a high level overview of what we just went through with the results. So you can see some of the same plots that we just went through, and then some kind of final takeaways and sort of CalEPA's interpretation. So like I said, there's a lot to go through there, and I'm not going to spend too much time with it right now, since we already covered a lot of it. But I also wanted to show a quick demo of the Shiny application. So that is available. So the link is available here, and like I said, the slides will be available online if you didn't already get the link, so you can get that link. So I have a little trouble navigating my windows. Right. So when you first go to this application, you'll get to the sort of landing tab that describes a little bit about what's available. Then if you, I'm going to actually go to the second tab, Redline CES analysis first. So this kind of walks you through some of the analysis that we just talked about and lets you sort of explore in a little bit more detail. So for instance, if you wanted to look at just the results for a specific indicator, you can do that here. And you can also pick which method you'd like to use to translate the CalEnviroScreen scores to the Redline maps. Then it sort of walks you through the analysis. I think we already looked at this before, and it just shows you kind of step by step that translation process. Then you can also see the scores that are CalEnviroScreen scores that get assigned to those neighborhoods, sort of broken out, so you can see visually some of the trends a little bit easier. And you can scroll around on the maps and view details about each one. Then it also walks through some of the analysis that we went through, some pretty similar plots. Also shows a little bit more detail of the results broken out by city, and kind of the same type of results that we looked at earlier with those sort of adjusted CalEnviroScreen scores compared across the state for the different neighborhoods, or the neighborhoods that were given each rating in the 1930s maps. And another plot showing kind of those average scores by city. So yeah, that kind of is designed to give you a little bit more detail if you want to understand more about the analysis or look at the different indicators. So there's also this tab, Maps and CalEPA data, that lets you take a look at the redlining maps in the context of the CalEnviroScreen data. So you can see the redline neighborhoods on the right and the CalEnviroScreen data with the redline polygons overlaid on the left. And you can also get some different data. So it's connected to different site data that CalEPA regulates. So try to select one of those. This is the CalEPA regulated site portal. Actually, maybe I'll try. Oh, yeah, go with that one. So you can see it gives you all the sites that CalEPA regulates that fall within those redline neighborhoods, and some other filters and things that I don't think I have time to go through right now, but you can check that out. You can also download the data to use offline in your own analysis. And there's a little bit of background information, so including the data sources that are used and links to all those. So if you would like to do your own analysis, those are available. So now back to slides. All right, so like I said, here's another list of the data sets that are used. Really briefly wanted to talk about the tools that were used, at least in my part of the work. I primarily used a programming language called R and a related tool, RStudio, to do most of the work. And those are free and open source. So sort of use those for the whole data analysis process, from access through cleaning and reformatting the data and doing the visualizations and the geospatial processing and then producing the reports. So that application that we just looked at was also done with R. If you want to get actually download R yourself, here's a link. The code and the data for most of this analysis is also on GitHub. That's kind of a lot to go over, sort of outside the scope of this presentation if you're not familiar with it, but it helps to kind of facilitate transparency, lets other people reuse some of the analysis and the data, and can promote collaboration. So really briefly, if you're not familiar with that, try to show the GitHub site, just to show you what it looks like. Right, so this is the page for this project. It's not super well organized, I will admit. I've been learning a lot lately about how to better organize projects, so might try to reorganize this one soon to make it a bit more user-friendly, but you can find things like all the code that was used to process the data for the analysis. So again, this is all the R code. A lot of the data that was actually developed is also here, so you can find a lot of geospatial data files that were used in the analysis and kind of produced from those combinations of the redline maps and the CalEnviroScreen data. So yeah, it's a quick overview of the GitHub. Lastly, really quickly wanted to go over some considerations for how to interpret this data. I'm speaking here kind of in more of a personal capacity, not necessarily the official CalEPA stance, but hopefully not too far from that. And given that this is a data project, data webinar, I wanted to quickly talk about maybe how to sort of interpret this data. There are certainly some limitations to this data set. It definitely has a limited geographic scale. So of course, limited to areas that existed in the 1930s and only the cities that had populations of at least 40,000. So given that, from what I understand, it can definitely be maybe not sufficient in and of itself to formulate specific policy. Of course, it can inform policy, but given its limited scope, it might not be sufficient in itself. So here's a report I found that I thought was kind of interesting that goes into that much more eloquently. Also, with this kind of analysis, I think it also often gets into discussions and arguments about correlation versus causation, and certainly that's an important thing to consider, I think, and there's actually some good reasons. And even from my trying to understand the history, found a few sort of historians that have raised some questions about how the maps were actually used, and how the loans given by this particular agency actually corresponded to the maps. Another interesting report you can check out if you'd like. But all of that said, I still think that this is important for a couple of reasons. I think it provides a good record of prevailing attitudes about race and credit risk that likely influenced other programs as well. And also, even though back to the sort of correlation causation issue, it's of course really difficult to prove causation with something like this, but we do understand a lot of the mechanisms that lead from the sort of input to the output that we're looking at. So I don't think it's a totally spurious correlation. So I don't think it's worth just throwing out all the findings just because we can't necessarily prove causation. We haven't necessarily drawn out the logic model or anything like that. I don't know if that's a possibility even. It's kind of beyond my current training, but I think that's definitely an interesting area of research and discussion. And finally, just with all that said, I think it helps us to understand the context for the work that we do. Again, another part of that report that you can check out if you don't want to take my word for it. So a few really quick next steps. Certainly the existing analysis could be improved on, more statistical power and things like that. Could include other indicators of current conditions relative to the Redline maps, or include other historical policies to kind of broaden the geographic scope. Not sure how difficult that would be, but definitely one idea. Or alternatively, potentially going and doing more of an in-depth study of a particular local area. So finally, I think, like I said, I think that this helps to inform and kind of support the work that we're already doing to ensure equitable access to clean air and water for everyone in California. And from CalEnviroScreen data, we already know that across the state, not even considering the limitations of the Redline maps, that people of color are vastly overrepresented in those areas that are most pollution burdened. So even the existing work and potential future work that we do just to address those areas that are most burdened can, I think, go a long way to start to address some of these issues. And that is it. Again, if you want to find the slides or links to the code, my email, it's all here. And also the overall kind of larger water boards data center also has a GitHub site and an email address. And that is it.
Wonderful. Thank you so much, David. You provided a lot of information there and covered the spectrum of the background and then got into the data analysis. That was a really interesting And I think it's wonderful that you made your slides available, because it was a lot to take in as you were going through them, but a good, really good presentation. We have, I know we're almost done with our hour, but there were a couple of comments or questions in the question and answer area in Zoom. So the first one you covered, what is the software package used to make the graph on slide 31? And then you went over the our studio information and showed us the GitHub site. Anna Holder noted that Waterboard staff can download R&R Studio from the Software Center, and then she provided a link on some more resources for that. And then we have a question of what factors were considered when assessing groundwater threats in the CalEnviroScreen scores, and how were those factors chosen? This may be more focused on CalEnviroScreen. I'm not sure if you
Yeah, I'm not sure if I'm the best person to answer that. So I think I might refer you to the CalEnviroScreen website and some other contacts that you might find there. I'm not actually in the CalEnviroScreen program, so I don't know all the details of each indicator's analysis, but I think it is pretty detailed analysis.
Okay, I have put the a link to at least CalEnviroScreen 3.0 version, which you referenced as what you're currently using for this in the question and answer, and then some thank yous. So since we are out of time, I will just remind everybody to fill out the survey link, or fill out the feedback survey that we Chad provided a link to if you have feedback on what you want to hear for future topics. And we will be posting the recording of this talk as well as our others in the College of Water Informatics events page. And we look forward to seeing you next week as we have our next seminar series this month, and Michelle Ting will be talking about Java and visualizations. So thank you again, David, and thank you all for participating today. Have a great day.